Precalculus, lesson 13.2, permutations with repetitions and circular permutations. Well, I hope lesson 1 made sense and that it is going well. As always, let me know if you have questions. So this is 13.2, and we said permutations with repetitions and circular permutations. So what we're doing is we're taking permutations from lesson 1, and we're just adding two varieties, two caveats, kind of two things that not necessarily unique situation, but different from just a regular permutation and how to accommodate for the situation. So, for example, dealing with repetitions. So let's say we had a set of items and a set of digits, and let's just say we had a 5 and 3 1s, and we want to know how many different permutations. Well, at face value, we have 4 objects, and if we're using all 4 of them, then we would have, permutations of 4 objects taken 4 at a time, and that's 4 factorial, which is what? 4 times 3 is 12 times 2, so that's 24. But is 5, 1, 1, 1 different from 5, 1, 1, 1? Where what I did is let's just say we call this one like the first one and the second one and the third one. Well, is 5 1 sub 1, 1 sub 2, 1 sub 3, is that different from 5 sub 1, 1 sub 3, 1 sub 2? Well, yes, if we have a way to distinguish each of these ones from each other. But if the ones are not distinguishable from each other, and we just have 3 different ones, then no, 5, 1, 1, 1 is not different from 5, 1, 1, 1. And or different from 5, 1, 1, 1 if I rearrange the ones, right? Because they're identical to each other. So what we do is we do this. We say with permutations, what we do is if there are, we'll say p repetitions of one object, and q repetitions of another object, then what we represent, or how we calculate this, is we get n factorial divided by p factorial and divided by q factorial. Now what's going on there, that's our formula for calculating repetitions. Permutations with repetitions. Oops, that starts with an R. I'll just put reps. With repetitions. So what's going on? If I use these ones, this 5 and these 3 ones as an example. If we look at how many different ways can you arrange those 3 ones? Well, the way that you can arrange just the ones is 3 factorial. Okay. So what we get is for each different place where we can put the 5, so we could have 5 at the beginning. Oops, too many. 5 at the beginning. We could have the 5 second. we could have the 5 third, and we could have the 5 at the end. Regardless of where the 5 is, we have 3 different ones, and we don't care about what order those 3 different ones go in. And so we divide by 3 factorial, which divides out the number of different ways that you can arrange the ones, if that makes sense. So what you can get into is stuff like this, like how many different ways, how many different arrangements can you form of the letters in the word. And I had a word in mind, but I suddenly want to see if I can come up with something slightly different. Let's go with... Nope, I don't like that one either. All right. Sorry, just one second. That's a good one. And the word centimeter. All right, so what we do is we look at how many total letters are there. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equals 10 because there are a total of 10 letters. And we look at how many repetitions there are. Well, for E, how many E's are there? 1, 2, 3. There are 3 E's, right? What other repetitions? We have a repetition of the letter T. There are 2 of those. And 1 C, 1 N, 1 I, 1 M, 1 R. So that's all the repetitions, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. I feel like there's a letter. Oh, 1 R. So only one of those. The E's, 1, 2, 3. I counted those. Okay, I counted the C. I counted the E's. The N, only one of those. The T, 2 T's. Yeah, I counted those. 1 I, 1 M, 1 R. So 5, 6, 7, 8, 9, 10. Yeah, that accounts for all of them. So then it would be 10 factorial divided by 3 factorial, because that's the number of different ways that you can arrange the E's for each arrangement. And then also divided by 2 factorial, because that's the number of different ways that you can arrange the T's for that arrangement. And I didn't grab my calculator. I thought I was all ready for this one. All right. Let's see. Well, so 10, that's going to be too big of a number. It comes out 302,400. That's what you should get there. Okay? Hopefully that idea makes sense. And then the circular stuff. Circular. So what's going on here is 5 items around a circle. So we have 5 spots here. 1, we'll say 2, 3, 4, 5 spots. And we have 1, 2, 3, 4, 5. Well, what if we took the same circle, also with 5 spots again? Sorry, that circle is terrible. And we started here. 1, 2, 3, 4, 5. And we ask ourselves, is this a different permutation or is it the same? And it really comes down to, is there a frame of reference that makes one of these different from the other? So, as far as the person in spot 1 is concerned, in the person 1 looks to his left and sees person 2, and looks to his right and sees person 5. Sees person 5, looks to her right and sees person 3. And that's the same in this arrangement. Look to your left, look to your right, you see the same people. So from that standpoint, these are identical to each other. So what could make them different? Well, if there was something
right here that marked a
care about. Okay, so if there's a reference point that we care about, then this is different from this. The first one is different from the second one because in the first one, person 5 is at the pillar, and the second one, person 4 is at the pillar. So if there's a point of reference that makes the circular arrangements distinguishable from each other, distinct from each other, then it's just a regular n factorial kind of situation. But if there's no
these
can we arrange these people without switching up who's sitting to who's left and right? Well, if there are 5 spots in the circle, then there are 5 different ways that you can rotate it and keep everyone the same relative to each other. Okay? So that gives taken n at a time with no, also I'll just go ahead and say with circular situation. In other words, no frame of reference. Now I've been using point of reference, I'll use the same. No point of reference. Then what we have is there are, in this case, we have 5 objects, right? So at face value, there are 5 factorial ways to arrange them, but there are 5 ways that they're identical. So what that would be divided by n, because if there are 5 objects, we divide by 5 because those 5 different ways that you can arrange, each of the 5 spots that you can rotate to don't matter. Or what's n factorial divided? Well, n factorial is n times n minus 1 times n minus 2, etc. And so if you do n times n minus 1, etc., divided by n, what you're left with is n minus 1 factorial. There.
so I guess one example we could give.
Oops. How many different ways? The whoops, because I dropped my stylus. How many different ways can you arrange 14 keys on a key ring? So we're assuming a standard key ring, there's no point of reference for which key is first and which key is last. Okay, so this would be a circular situation. So that would be 14 minus 1 factorial, which is 13 factorial, which gives you 3,510,400 different
14 keys on a key ring. Okay. That, I believe,
for this lesson. But again, as always, let me know if you have questions. Hope it goes well. See you next time.